Good morning, good afternoon, and good evening, depending where you are. Obviously, it's a virtual conference, so you could be anywhere. I'm based in the UK, so my name's Jamie Coleman, and yeah, it's dark outside now. Okay, so I hope you've all enjoyed the conference so far. Let me just get into what we're going to talk about here. Like I said, my name's Jamie Coleman. I'm a software developer and advocate at IBM, mostly working on the Open Liberty teams, or basically anything Java these days. So work a bit MicroProfile and Jakarta EE and things like that. And today we're going to be talking about Paketo, if you've never heard of it. It's something that I've been playing around with for a few months now. And yeah, it's really, really quite cool. But I won't ruin what we're going to talk about in the presentation. So what we're going to talk about today. So first of all, we're going to talk a little bit about what polyglot applications are, why you would bother using different languages in your applications rather than just sticking to Java, for example. Then I'll talk a little bit about what a build pack is and how it can help with things like compliance, security, control, maintainability. Then we'll move on to Paketo. That's what this whole presentation is about. We'll talk about what it is, how it works with things like Java. Then we'll talk a little bit about the Open Liberty build pack for Paketo and the Open J9 build pack. And then I'll show you how to kind of get started with Paketo. I'll introduce the runtime we're going to be talking about today, which is Open Liberty. Talk a little bit about what MicroProfile and Jakarta EE are, in case you've never heard of them. And then hopefully, if the demo gods and everything's smiling on me today, I'll give you a little demo of using Paketo with things like Open Liberty. So what are polyglot applications? Essentially, a polyglot application is an application that's written in lots and lots of different, well, in multiple languages. It's the reason we use multiple languages in the creation of our applications is things like to capture additional functionality and efficiency of different languages. So there might be some things that Node can do a lot better than Java. There might be things, obviously, that Python can do better than Java and things like that. So it doesn't always make sense to stick with one language to design your whole system. This allows development teams to choose the technology stack they want to use, providing you're creating your microservices, you're using things like API first, etc. It shouldn't be too difficult to do. And if you, like I mentioned, if you abide by the 15-factor rules, which have been revised, it used to be the 12-factor, now it's been revised to 15-factor. And if you follow things like API first, then it shouldn't really matter if your teams are using different languages, as long as you kind of design your API and document it first, so other people know what they need to do when they're talking to your microservice. Right, so a thing we should care about, and this kind of goes back to the efficiency and why we would use different languages. Now, we want our applications to be as efficient as possible, and so for us developers, well, for our organizations, that might save them a bit of money, but for us developers, what I think that means is we can save energy. So like I mentioned, so there's 500,000 data centers around the world, probably a few more now. They consume a hell of a lot of land, so 6,000 football pitches or soccer pitches, as this is an American conference. And they use the equivalent of 1.5 times the whole United Kingdom's energy supply, and that was in 2019. So it's probably much higher than that now. Luckily, the hardware engineers are doing their part. They basically, with all the advancements and all the changes in hardware efficiency, they've managed to cut the trends of how much energy we're consuming with our data centers. And as you can see by the graph here, if those improvements weren't made to the hardware, we'd be using a hell of a lot more energy. But as we're engineers, I would say it's our responsibility to make our applications as efficient as possible, try and save as much energy as possible, and as a consequence, save our organizations a bit of money. So another reason why Java might not always be the perfect language for microservices is, for example, you have the JVM, which is quite a big part of the stack. Now, of course, JVMs are really designed to run lots and lots of applications, whereas now we're basically putting our application, our runtime, and our JVM all together, and the JVM is quite a big part of that stack. So that, things like that, it's a big overhead when you're creating microservices. Now, JVMs have changed over time, so trying to focus on things like startup time, ramp up time, memory footprint, response time, and CPU and throughput. But when you make changes to some of these some of these metrics, then it can have detrimental effects on the other ones. So say if we manage to make the throughput much higher, it could have a detrimental effect on startup time. So the JVM I'm going to be showing you with a demo today is OpenJ9. There is a build pack for the OpenJ9 JVM. And really this was IBM's Java. It was open sourced about 5 years ago now. Yeah, it was 5 years ago last week, I think. And really, so this JVM has really gone, it's been used by some of the biggest enterprises in the world. It can handle really constrained environments. And if you've got very memory-rich ones, then it'll have great throughput. And the good thing about that is when we're working in this containerized world, a lot of the problems, because we're buying units of resource, and if we run out of that resource, our applications can then crash, etc. Whereas when we were running this on our own servers and when we weren't using containers, we didn't have the limits that we do now when we're renting hardware. And OpenJ9 is great because when you have a restricted environment and you don't have much memory, the throughput can still keep up. Whereas some of the other JVMs, if they run out of memory, their throughput just hits the floor and basically your application stops working. And yeah, just some stats about OpenJ9. This is from the OpenJ9 website. For example, faster startup time, smaller footprint, things like that. And these are things that can help our Java applications become more efficient. So I came across this article on LinkedIn actually not long ago, which was really, really great because I'm very kind of into, efficiency. I'm very kind of big into efficiency and trying to drive companies, etc., to make the most efficient applications. And this research basically looked at all the different languages and basically kind of rated them in regards to their energy consumption and what they use. And it's quite good to see Java is in the top 5 of languages for efficiency, especially as it's quite an old language now. So that is really, really good. But again, there are lots of different languages, and the whole point of polyglot applications is you can mix and match which ones you want to use. So yeah, advantages, for example, increase engineer creativity. If they've got the freedom to use any kind of stack they want, etc., they're going to be a lot more creative. Whereas, say, for example, you have to use Python for this or you have to use Java for this. If done correctly, it can speed up the time to market, because if you've got engineers that are enthusiastic about the stack they're using and they know the technology well, then it can speed up the time. Reduce the time it takes to get your applications out there. You can draw from a bigger pool of talent. Of course, if you're using just one language, generally you're only going to hire Java developers, for example, whereas if you give people more freedom and you use polyglot applications, you've got a bigger pool of talent you can draw from. And more efficient applications, that's the whole point. One of the main points of using polyglot applications is to make them as efficient as possible. Now, there are a few disadvantages. Scaling issues can be sometimes a bit of a problem when you're dealing with, lots of microservices written in different languages, and it can add complexity. Of course it can. If we're using the same language to create a whole system, then it's going to be a little bit less complex than essentially using lots of different languages. But this is where build packs come to the rescue. So what is a build pack? So a build pack essentially takes your application source code and transforms them into OCI images, so you can use them pretty much anywhere. It was conceived by Heroku, and the Heroku were the creators of the 12-factor application in 2011. And they kind of came together with Pivotal in 2008 to kind of merge the work they were doing to create what we have today, which is build packs. Right, so what do build packs offer? Right, advanced caching. This can help improve performance, auto detection, which we'll see today. Basically, you can build images from source code and you don't have to configure them or do anything. You just point essentially Paketo and one of these build packs at that source code and it'll do everything for you. Something that's really useful is it can create a bill of materials, and this can give you insights into what the contents of your application are. It's modular and pluggable, so you can use lots of build packs to create one image. So today we're going to use 2 build packs to create the image we're doing. It'll be the OpenLiberty one and the OpenJ9 build pack. Again, multi-language support, one of the main reasons that I'm advocating for these, because it basically takes some of the complexity out of having to deal with lots of different builds of lots of different languages. And I've got multi-process, so images can have multiple entry points, minimal app images, so make them as small as possible, because again, we want them to be efficient. You can apply instant updates on the base image, so your OS, etc., or something like that, without having to rebuild it, which is good. You can reduce the same app image every time, and reusability, so you can leverage pre-built build packs maintained by a large community. So, for example, Open Liberty, the build pack there is maintained by the development team in IBM. So some of the main things that build packs help with, so compliance is a good one, essentially assuring that your license are being correctly used. And so some of the top reasons for non-compliance, generally complexity of software licenses, inadvertent misuse, lack of software asset management procedures and tools, lack of education, or just kind of internal misuse. The main two that build packs kind of help solve is the inadvertent misuse and the lack of software asset management procedures, because it can produce, for example, SBOMs, bills of materials that can help you look at the licenses. Stacks and build packs. So ensuring your stacks are updated and secure. This is really, really, really important nowadays. And basically, a build pack that Paketo uses is, like I mentioned, the notion of a stack. You have your build image, which that basically provides a base image for what your environment's going to be constructed from, and the run image, and that's of a stack that provides the base image from what your applications are going to be built. So what kind of security and hardening features does it have? So basically, by using the Ubuntu 18.04 and 22.04 as the base image of your stacks, you benefit from getting all the security provided from Canonical and Ubuntu, which is amazing. So automatic monitoring done by the build packs and Paketo, monitor and patching CVEs means that your stacks are often updated within hours of patches coming out, which is great. The stack images are run as a dedicated non-root, which can help harden your security on it. Each stack image has detailed metadata describing the image's components, such as the base operating system and the packages it contains and what versions they're at. So good if you're doing your auditing, etc., and you need to make sure that you've got the right packages installed. Each stack has a separate image for building and running applications. So the packages on the runtime image are curated to exclude compilers and other tools that might pose security risks. And the build and run images have different user IDs. That means that sensitive files and dependencies installed at build time cannot be corrupted and run at runtime by malicious code. So control. With build packs, you basically have full control over the open operating systems, languages, and the pack management your teams can use. This allows you to connect to, for example, a private Maven repository and use dependency management software such as Sonatype's Nexus products. And this basically will scan through kind of your dependencies and make sure they are secure, because nowadays we use a lot of different open source software around the world. And it's very easy to forget that all these dependencies we're using might have vulnerabilities in. They also, like I mentioned, they also provide you with a bill of materials through standard build times and loads of different formats. So you can take these insights and then use them with any other kind of software to basically make sure everything is at the right version and you haven't got any bugs, etc. Maintainability. So this is something quite important, especially to nowadays, as we're creating lots and lots of applications as opposed to one big one. So having good maintainability helps you organize and save money and energy in the long term. And build packs offer certain features that can help with that, such as auto detection of your source code, which we'll look at later. Using multiple build packs to create one image, like we mentioned. Images that only contain what's required. Like I mentioned, instant updates on the base images without having to rebuild them, which is amazing. And you can reuse build packs maintained by a large community. And there are quite a lot of build packs out there. So if we're just going to compare build packs to some of the other kind of existing technologies that maybe it will be a competitor to this. And again, this is all open source. I'm talking about build packs here. And like you can see, I don't think there is many other solutions that offer kind of what the cloud native build packs do. And it does honestly make your life a lot easier. And I'll try and demo that in a moment. So we're going to introduce Paketo. So what is Paketo? Paketo basically uses these build packs. So it transformed your application source code into container images. And Paketo is open source, same as the build packs, and provides production-ready build packs for the most popular languages, so such as PHP, Java, Node, Go, Net Core, Ruby, stuff like that. It allows you to easily build applications and keep them updated. So how does it work? Well, pretty much you don't have to do a lot. You kind of you have to install obviously the CLI and the pack CLI they call it. And once you've got that, it's very simple. You just kind of go to your source code directory, and basically it'll figure out what language you're using. And it'll figure out what build tool you're using by the directory structure, and it'll also figure out what runtime you're using as well, which is amazing. And you can use lots of different build tools for this, so things like Gradle, Maven, Lening, and SBT. So you can install specific JVM versions as well, and use alternative JVMs. So lots of different choices here. And Paketo, you can use alternative Java application servers from the default. So it's entirely up to you what runtime you want to use. When deploying Java applications to an application runtime, the default application server installed by Paketo is Apache Tomcat. But but what this will do is we'll look at our application code and our file structure, and it will know I'm already using OpenLiberty, so that's the runtime it will use. So quickly going to introduce OpenLiberty. So OpenLiberty is a runtime that was released the same time as OpenJ9. It's completely open source and it's run by IBM. And OpenLiberty kind of has, it was OpenLiberty's 5th birthday. That's how I know OpenJ9 was released about 5 years ago, because I think they were done at the same time. But OpenLiberty just had its 5th birthday, hurrah! And the project goals for OpenLiberty have always kind of been to focus on code, to allow developers to do what they need to do rather than worrying about runtime. We want to make fast and iterative changes. So there's things like dev mode, which enable that. True to production testing, so being fully compatible and supporting things like test containers. So one of my first jobs at IBM was in the container team for WebSphere. And so with WebSphere, we basically, it was, I think, one of the first IBM products to have a Docker container. So I had just come out of university at the time, and I didn't really know what a Docker container was. But yeah, we were one of the first products at IBM to be containerized. And of course, through that, we've tried to make the container as efficient as possible. So dev mode. Dev mode essentially allows you to start the runtime and make changes to your code, make changes to your tests, make changes to your configuration, and not have to keep restarting the server. Those changes are always picked up in milliseconds. So by the time you've got back to your browser or whatever to test the changes you made, they should have already been deployed. Because at the end of the day, developers, we don't want really to have to worry about the runtime. We just want it to work. So developer productivity has kind of been at the heart of OpenLiberty from the beginning. So supporting the main IDEs, having our stuff in the main repositories, etc., using the latest and greatest build tools, supporting the main API, so things like MicroProfile and Jakarta EE. That's what we're going to use later. We're going to deploy a MicroProfile and Jakarta EE application. But it also supports things like Spring Boot, and it has some amazing performance benefits using Spring Boot, like nearly double the throughput. So do check out, if you are using Spring, do check out OpenLiberty and what it can provide you. So 6 reasons why Liberty. So it's just enough runtime. So 80% disk and 50% memory savings. Low operating costs, so 4 times increased density over Tomcat and Spring Boot. And again, you can use Spring Boot with OpenLiberty. Continuous delivery. So basically, we're constantly releasing new versions all the time, and that kind of leads into zero migration as well, because it can always be annoying moving up to the latest version of something like a runtime. You've got to do lots of testing, but OpenLiberty has the policy of zero migration. So you should be able to move up to the latest version, and the theory is that your code shouldn't break. So it's good because it allows people to get the latest versions and use the latest functionality and technologies rather than being stuck on a version for say 1, 2, 3 years or something like that. Optimized for Kubernetes. It's got a self-tuned optimal. It self-tunes its threads, etc., and things like that, which is awesome. And again, we've been building these images for. I've been doing it for like 8, 9 years now. So it really is. It really is optimized for containers, and a good developer experience. So like things like dev mode help with that. So OpenLiberty and Paketo. So there is an OpenLiberty build pack, like I mentioned. The Paketo build pack for Liberty is a cloud-native build pack that contributes OpenLiberty or WebSphere Liberty for Java EE, Jakarta EE, and MicroProfile support. So you can go check that out. That's available on GitHub. Just Google OpenLiberty Paketo build pack, and it should come up. The build pack will support all available profiles of the most recent versions of the Liberty runtime. Because the Liberty versioning scheme is not conformant to semantic versioning, a Liberty version like 22.0.2 is defined as 22.0.2 and should be referenced as such. So getting started with Paketo. So the first thing I would advise is to look at Paketo and at your own applications using things such as SBOMs and decide on what technology you want to use. If you're working for a big corporation that decides what technology to use when then creating an SBOM is useful to determine if you need to purchase extra licenses and not incur any extra license fees because you don't want people chasing after you for not paying your license fees or buying the software you're using. MicroProfile and Jakarta EE. So I'm going to just quickly introduce MicroProfile and Jakarta EE because we are using a MicroProfile and Jakarta EE application today. Very, very simple application. But I presume a lot of people mostly have heard of it already. So MicroProfile, what is it? So MicroProfile is an open source community specification for building Java microservices. Because at the time, there wasn't really an open source specification that was really for Java, enterprise Java, that was geared towards creating microservices. And essentially a community of individuals and organizations and vendors all collaborate together to basically bring MicroProfiles to life. So these are some of the contributors to MicroProfile. Without them, MicroProfile wouldn't be where it is today. And these are some of the vendors. And the great thing about this is it's vendor neutral. So you can go, you can change vendor if you want, and they all adhere to the same kind of standards, which is really good of the specification. So this is the MicroProfile stack. As you'll notice, some of the stack is shared with Jakarta EE. That's mainly because they didn't want to develop two things in parallel. It didn't make sense. So it made sense to rather just develop it in one place and then take that specification into MicroProfile. And there are some standalone projects. So if you're using reactive programming, if you're doing reactive architecture and things like that, and reactive messaging and reactive stream operators is really useful and works really, really well with the MicroProfile specification. What is Jakarta EE? So this is what Java EE has become, and it's an open source community-driven specification for cloud-native enterprise Java, so not specifically for microservices. Jakarta EE is a set of specifications, and it actually extends on what Java SE for enterprise features, such as web servers, services, etc. These are some of the members, strategic members, and some of the participating members in Jakarta EE. So thank you to all of those. And the good thing about Jakarta EE roadmap is new versions are coming out quite quickly. This slide's a bit out of date now. I should probably update this. But rather before, it took quite a long time for a new Java EE version to be released, but now the community is running it. They're striving to release a lot quicker. And again, going back to OpenLiberty with zero migration, it's really great because you can move up to the latest version of Jakarta EE and your application shouldn't break as well. I'm going to try a little demo now. You can follow along if you want. You will need to download the pack CLI. And we've also, if you go to the link in the slides, openliberty.io/guides, if you pick any one of the guides there is a running cloud button. That'll essentially take you to a cloud environment, which has everything set up for you. Again, the only thing you're going to need to install is the pack CLI. Right, so let me try and give a demo. Okay, so let me just start the application up so you can see what we're working with today. Again, it's a really, really simple application to make things simple. I'm just going to start the application using Maven. And let's have a look. So this is the application here. Like I said, very, very simple. And all we're really doing here is essentially creating a REST endpoint that will provide the system properties of the machine we're running on. Now, when I'm running this locally, we should see the system properties of my current machine, but then when we run this using Paketo, etc., we should see the system properties of the container it's running in rather than the application itself. So just let that start up a moment. To access the application, it's just heading to localhost 1980/system/properties. So hopefully it should start up in a moment. Need some elevator music. All right, okay, so I'll just drag that over here. So as you can see, these are the system properties of my environment. So my local computer. So I'm going to shut this down now. You can do that, just Control-C, nice and easy. And then I'm just going to package up the application and we can get started. Right, so I don't think technically you need to package up the application. Paketo should take care of that for you, but I'll do it anyway, just in case. So again, like I said, you need to download the Pack CLI to do this. Just check by just typing Pack, it should come up. So like I mentioned, Paketo build packs are an open source project which provide users with production-ready build packs for the most popular languages and frameworks, and OpenLiberty is one of them. So a build pack, like I mentioned, is a set of executables that inspects and transforms your application source code into OCI images that can be ran on nearly any container image manager. So let's get started. I am going to, first of all, what we need to do, we need to set our default builder. A builder in the build pack ecosystem is an image comprised of 3 parts: a set of build packs, a stack which provides the operating system layer for your application image, and a lifecycle which analyzes, detects, and assembles your final application. So to do that, nice and simple. So I'm just going to set the build pack to the default one, which is probably okay because I think I already set that, so we should be okay. And then we're going to go build our application. Now I'm going to copy and paste this in, but then I'll explain what it means as we go along. So we're basically saying build the --m are just providing environment variables for Paketo to use. And then essentially, as you can see, we're setting it to the build packs OpenJ9 and then Java. So nice and simple. And the application we want to create. Let me hit the. Failed to build. Blah, 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 blah. All right, Docker. Okay, that would make sense. Need to turn Docker on. At least it actually provided a nice error, which told me what exactly was going on. So I'll just give it a second for Docker to start up. But yeah, like I mentioned, so we're just basically here, we're basically just providing some environment variables. We're saying the app server is Liberty. We're saying the target where we've built our application to. And then, yeah, setting some more. We're setting the Liberty profile, so we're going to be using Jakarta EE MicroProfile. What else? Anything else interesting? Again, we're using the OpenJ9 build pack, Java build pack. So yeah, all right. So hopefully Docker is now all done and ready. Let me just check. Yep, that's all good. So let me just run this. Okay, good. Again, I've already downloaded the images. So the images that will probably be downloading is OpenJ9 and OpenLiberty, etc. Very strange. All right, it should be okay, but we'll go through that in a second. What else? So right, so now we basically just kind of run our application. Let me just double check this again. It might be okay because I built it earlier. Of course, the demo gods aren't happy with me today. All right, but essentially what this would be doing, if it was working, which it did work earlier, essentially it would just go looking at your application source code. And again, I've got no configuration files here, nothing at all. And it determines you're using Java, it's determining I'm using OpenLiberty, and then of course, it's downloaded the OpenJ9 build pack. So let me just run the application now. I'm running in a Docker container, so I'm just using Docker to run that. Should start up just to make sure. And again, I did build this earlier. I don't know why it's complaining now. Yep, it's all up and running. So now I should be able to go back here. It might take a second. Oh. Try and hit it. So we need to hit localhost system properties. All right, give it a second just to start up. And then when it started up, we should see the system properties of our Docker host. But yeah, so what I'm just trying to demonstrate is how simple it is, although the demo gods aren't happy with me today. But essentially, yeah, there we go, lovely. So as you can see, the system has changed because obviously now it's reporting on the system that is inside the container as opposed to just running locally on my system. Right, I'm going to shut this down. Have a chat message. 5 minutes left of your presentation portion. No questions yet. All right, awesome. Right, so let's go back to the presentation then. Yeah, I'm not sure why the that wasn't quite working. Just to kind of recap of everything we talked about today. So polyglot applications are great. They can provide lots of benefits. They can make your applications more performant, more efficient, but they can make your whole system a bit more complex. And build packs can help with things like that, using advanced caching, auto detection, providing you with a bill of materials. It's modular, multi-language, multi-process, etc., etc. And OpenLibity and MicroProfile with Jakarta EE are great open source choices for your Java applications. Are created to be very efficient and are fully supported by build packs that are maintained by the OpenLibity development team. If you want to find out any more information, there is links to some of the research that I talked about today. I will upload this presentation later. And there's some more links to some of the material we talked about today. And everything I've used today, I've talked about, is all open source. So there's no excuse not to check any of this out. And going back to the importance of things like security, now we are using lots of open source stuff. We need to make sure that we can verify that there isn't vulnerabilities in the stacks we're using. If you do want to reach out to us after this session, feel free to. We are around on LinkedIn and Twitter, or you could just fire us an email. And if you want to inquire about anything or talk to me on Twitter, etc., my Twitter handle's there. So I hope you have enjoyed this session. I hope you're enjoying the conference so far. Sadly, I couldn't come to nice, warm Florida, but yeah, maybe next year. So yeah, if there are any questions, please ask away. If not, then I will end the session. I'll give it, say, 30 seconds just to see if anyone asks any questions. But I think we're all good. All right. Well, with that, I will close the session. Again, you can ask me some questions on the conference application. But yeah, thanks for having me today. It's been a pleasure talking to you all. And again, I hope you enjoy the rest of the conference.